Hi, hello. In this video, we are going to learn about a very important tool in hypothesis testing, the decision-making tool. The tool that is going to let you understand whether you can trust on your experimental findings or not, right? And that is none other than probability of significance. We shortly call it as p-value. So this is what we are going to learn in this particular video. P-value, the probability of significance, and then the decision rule using p-value. In the previous lessons, we learned about type 1 error and then type 2 error. Type 1 error, if it is limited to 5%, our confidence level is 95%. So how much is the type 1 error in our experimental study? How do you find out an answer for this question? P-value will answer it. So p-value will let you understand, or p-value can give you an estimate of the type 1 error. If the type 1 error can be estimated, then immediately the confidence level can also be estimated. If the estimated confidence level is 95%, then you can make a conclusion that what you observed in the experimental study is true in real time. That means what you observed, the difference you observed in the experimental study is considered to be significant. You can trust your data and then take decision only when p-value is less than 5%. Because only when p-value is less than 5%, which means type 1 error is less than 5%, which again means your confidence level is 95%. So it's important that you understand clearly about p-value. That is what we are going to do in this video. So what is p-value? P-value is also known as probability of significance. It is the probability with which a random chance could have generated the data in your experiment. That means being data driven is good, but what if your data misleads you? Because whatever you observe through a data, sometimes may also be false, right? I did an experiment and I observed something. If I repeat the experiment, the exactly opposite thing can also happen, isn't it? These are all possible. So because our study is sample study, it's a limit, it will definitely have a limitation. Just because you observe something in the sample, you cannot say that the same thing you will observe in the population also. Depending on the number of samples, depending on your, the sampling technique, depending on, the difference in the statistics you wanted to validate, there will be, an amount of error. And then there will be and then, accordingly, the confidence level will get affected. Accordingly, the power of test will get affected. So we should find a way to estimate the amount of type 1 error that we may encounter, while making decision using our experimental study. So in order to get an estimate of the type 1 error, we use a tool called p-value, which is probability of significance. So what is probability of significance? It is the probability with which a random chance could have generated the data in your experiment. I observed something in my experiment. That means, I expect the same thing to happen in the next time also. When I repeat the experiment, the same thing I should observe. Suppose if I repeat the experiment and I don't observe the same thing, what does it mean? Then first time what you observe is due to a random chance, a mere luck factor, or you can say, or a mere coincidence, you can say, isn't it? But if whatever I observe, if the same thing is going to repeat again and again several times, that means, my confidence level will increase. Whatever I observed in my sample study, if that is not going to happen in the repeated experiments, that is, going to pull down my confidence level. And that is what, we call it as the error. If your confidence level is pulled down, that means, error. Suppose, let's say I repeat my experiment 100 times. 5 times, what I observed in the experimental study is, not getting repeated. But 95 times, whatever I observed in the experiment, is getting, same thing repeated. That means my confidence level is 95%, and then, the error is 5%, right? So always any experimental study will have this error will also have the confidence level. The p-value will give you an estimate of the error, right? P-value will give the estimate of the type 1 error. So p-value is the risk of observing the data due to a random chance. Whatever you observed in your experimentation may be merely due to a random chance. Anything can happen, isn't it? So what is the probability that what we observed in the sample study, could have happened completely due to a random chance? That means you found some impact, but it is not actually due to the factor. You found some impact, but it is actually not due to the factor. For example, if sometimes the students studying in a class, they pass the subject, without even attending the class, isn't it? So actually, if you don't attend the classes, probably you may fail. But what happened? Your luck, you have not attended the class, but still you are able to clear the exam. And there is always certain chance for these kind of events to happen randomly. So this is what we are trying to estimate. Similarly, the other thing is also possible. You studied very well, but still when you actually appear for the examination, you may you may give your exam badly, and then you may fail. So always there is a risk involved. No, that is what we call it as the error. So the p-value will actually measure that error. So p-value is an estimate of type 1 error we may commit while rejecting the null hypothesis in the hypothesis testing. The null hypothesis is true, right? Your null hypothesis is true, and then you reject. And this is what we call it type 1 error. If the null hypothesis is false, and then you reject it, that is called power of test. Or if the null hypothesis is true and then you accept it, that is called confidence level. So when you are rejecting a null hypothesis, isn't it, you should be very sure that it is not true. When the null hypothesis is not true, then only I will reject. But when the null hypothesis is true, still I reject, and that will lead to type 1 error. So the p-value will actually give an estimate of the type 1 error. And so what we want is a lower p-value. When the p-value is lower, then what will happen? Your confidence level will get boosted. When the p-value is less than 5%, then your confidence level will be more than 95%. So when you wanted to take a decision, whenever you collect a data, right? Whenever you do an experiment and you collect a data, using the data, using the central tendency in the data and using the variation in the data, a p-value, right? The probability of significance can be calculated. This p-value is the risk of observing the data due to random chance, right? So instead of simply believing the data, I will believe the data only when the p-value is low enough. Only when the p-value is low enough. Always the level of significance is 5%. That means the tolerable type 1 error is 5%. So I will always believe my data only when my p-value is less than 0.05. So the decision rule using p-value is, if p-value is less than 0.05, I will reject the null. Otherwise, I don't reject, because when p-value is more than 0.05, still I reject, then what will happen? My type 1 error will be more than 5%. When type 1 error is more than 5%, my confidence level will be less than 95%. So generally, it is expected that you do experimentation and then make conclusion at least with a 95% confidence level. So you can reject the null only when p-value is less than 5%, which is 0.05. Whenever you see a p-value of less than 0.05, then you can make a conclusion that your X factor has an impact on the Y response, because you have rejected the null. You know what is your null? P-value has no impact. You reject it. That means your X factor has no impact, and since your p-value is less than 0.05, you reject the null, and then you can conclude your X factor has an impact. Whenever you reject the null, alternate can be accepted. Coming on to the other side, when your p-value is more than 5%, that is more than 0.05, then you have failed to reject the null. You fail to reject the null, simply, it is as good as accepting the null. So if p-value is more than 0.05, you need to proceed with the null. Then what is your null? X factor has no impact on the y variable, because null hypothesis is always a statement of no impact. This is how we make use of the p-value to take decision on our null hypothesis. Our null hypothesis is either we reject or we fail to reject. And we reject the null only when p-value is less than 5%. And we fail to reject the null whenever p-value is more than 5%. Hope the lessons are very clear to you. And then I will meet you again with some more interesting tool in the next video. Thank you for watching.